Okay. I'm trying to figure out how to get rid of that. Anyways, so we are back. We are now on page 4. We're still in section 12.1 and 12.2, but we're going to be looking at how to use the constant acceleration equations. So remember, if we took our functions of time equations that we have back here, and we integrated these with respect to a constant acceleration, then we get these, I call them the easier equations. You just plug and chug, okay? So if a particle has an initial velocity of at position, determine its position when, if, so right here, a equals 2, that's a constant. So I know that I can use constant acceleration equations. So I have an initial velocity of 12 to the right. So that's at s equals 0, determine its position when t equals 10, if a equals 2. So we know our initial, and we want to determine its position. So we do not know the final velocity. So that might make this one hard to determine our final position since we don't know that. So let's look over here. We don't know final velocity. We're looking for final position. I know initial, time, and acceleration. So S equals S naught plus V naught t plus 1/2 AT squared. So I'm going to have 0 plus 12 times, my time is 10, plus 1/2. A is 2 times time squared. And also make sure your units, everything is in feet seconds squared second, so we don't have to do any type of change with our units. So if we fill this out, we're going to get that S equals 20 feet. Okay, a particle travels in a straight line with it tells us constant acceleration. When s equals 4, v equals 3. When s equals 10, v equals 8. Determine acceleration. I don't see any time in here. If I don't see time, I'm usually going to try to go to that equation right there, especially since we're determining acceleration. So I have my final is my initial plus 2 constant acceleration, final minus initial. So when S is 4, V is 3. When S is 10, V is 8. So this is going to be my initial and my initial, and this is going to be my final and my final. So I have 8 squared equals 3 squared plus 2 acceleration, 8 minus 4. And if I work all of this out, I should get that my acceleration is 4.58 feet per second squared. And again, always make sure that our units are matching, okay? Initially, a car travels along a straight road with a speed of 35 meters per second. So we have meters in seconds. That's our velocity, so initial. So that's the initial velocity. If the brakes are applied and the speed of the car is reduced to, so here's our final velocity, and here's a time, determine the constant deceleration of the car. And so I'm not going to try to put in a negative because putting in my final and my initial is already going to make the negative showing that deceleration. So if I have a velocity, and a time, and I'm trying to figure out an acceleration, I don't know anything about position change. Here is the equation I'm going to look at. V equals V naught plus AT. So my final velocity is 10 meters per second. My initial is 35 meters per second equals that plus that constant acceleration times 15. So see, I'm going to do 10 minus 35 equals 15 AC. That's how we get the negative showing that it actually is deceleration. So our acceleration is negative 1.67 feet per second squared. So again, our car is going forwards. That's our positional change, but our velocity and our acceleration are acting opposite to that. Okay, traveling with an initial speed, velocity equals 70 kilometers per hour. A car accelerates. I know that's constant because it's a constant number. So my acceleration is 6,000 kilometers per hour squared along a straight road. How long? So I'm looking for time. And if I'm looking for time, Here's my two time equations. Will it take to reach a speed of? So my final velocity is 120 kilometers per hour. Also, through what distance does the car travel? So the first thing I'm looking for is time. So I know V naught A VF. I'm going to go with this equation. V equals V naught plus AT. So I have 120 kilometers per hour equals 70 kilometers per hour plus acceleration is 6,000 times time. And I'm going to get that my time is 0.00833 hours. That's a ridiculous number. So let's convert that to seconds. There are 3,600 seconds per hour. So my time is 30 seconds. That makes a lot more sense to my brain. Now we're wanting to know that positional change. So I have two ways to do this. I now know the time, and I know that I'm starting at 0. I know my initial velocity, my acceleration. I know the time, so I could determine position that way, or I could use this and just determine that position. So here we have v squared equals v naught squared plus 2as minus s naught. Start filling those things in. So I've got 120 kilometers per hour squared equals 70 kilometers per hour squared plus 2 times 6,000 kilometers per hour squared. And that's going to be my positional change in there. If I work this out, my positional change is 792 meters.